Welcome to Find Bugs Minutely Unraveled Series Part 2. Well, in Part 1, we discussed the fundamentals such as setting up the FindBugs plugin in Eclipse environment. We also saw about the open source code on which FindBugs is implemented. We finally discussed about the bug distributions across various different bug categories. Well, now it's time to classify the bugs based on its rank. In ESMSKA project, FindBugs has discovered 4 scary bugs, 17 troubling bugs, and 72 of concern bugs. So what are the ranks of these kinds of bugs? Bugs with a rank between 5 and 9 are classified as scary bugs. Bugs with a rank between 14 and 10 are classified as troubling bugs, and bugs with a rank between 15 and 20 are classified as of concern bugs. In this podcast, I am going to talk about two bug patterns, one of type scary and the other of type troubling. First, let's talk about the scary bug that FindBugs has found in this project. The scary bug that I would like to discuss about has the bug pattern as RCN redundant null check would have been a NPE, and the category this bug pattern falls into is correctness. This bug was discovered at line 1639 in config.frame.java file in esmska.gui package. The bug ranking of this pattern is 9. The description of the bug says, a value is checked here to see whether it is null, but this value can't be null because it was previously dereferenced, and if it were null, a null pointer exception would have occurred at the earlier dereference. Essentially, this code and the previous dereference disagree as to whether this value is allowed to be null. Either the check is redundant or the previous dereference is erroneous. The description matches with the scenario that I observed in the code. Gateway is an object of the class gateway, which is representing a web gateway. This implementation caches all information retrieved from the gateway script in order to reduce the performance impact caused by JavaScript invocations. Gateway object is used in two locations, one followed by the another. In line 1639, a method has feature is invoked using this object where it returns true if a particular feature exists for the selected gateway. This is the first location where gateway object is used. Then in line 1659, gateway object is again referenced where it is checked for null value in an if condition. Then the result is assigned to a variable called key. Then the variable key's value is again checked whether it is null. The point here to be noted is that the gateway object is redundantly checked for null value storage, once in line 1639 and again in line 1659. If there had been a null value storage in the first occurrence, that is, in line 1639, a null pointer exception would have been thrown there itself. There isn't really a need to do the null check again in line 1659. Hence, this bug being reported proves to be a valid one. Before we proceed to the analysis of the next bug pattern, I would like to describe the internal working of this detector RCN null check in brief. Firstly, we have a null dereference and redundant comparison finder class which performs a whole lot of functionalities. It checks all the methods for potential null dereference and the redundant null comparisons. Next step is to examine the null values. Report those values are guaranteed to be dereferenced on non-implicit exception paths. For each of the potential null value collected in the previous step, identify all the locations where there are chances for it to become null. One another thing that need to be taken care of is to check for values that are dereferenced unconditionally in a control flow graph. Finally, these values have to be reported. Next, I would like to analyze a troubling bug type with rank 10. The bug pattern is LG lost logger due to a weak reference, and the category this bug pattern falls into is experimental. This pattern is reported at line 34 in log support.java file in esmska.utils package. The description of the bug says, OpenJDK introduces a potential incompatibility. In particular, the java.util.logging.logger behavior has changed. Instead of using strong references, it now uses weak references internally. That's a reasonable change, but unfortunately, some code relies on the old behavior. When changing logger configuration, it simply drops the logger reference. That means that the garbage collector is free to reclaim that memory, which means that the logger configuration is lost. The description of the bug seems meaningful when it is compared with the scenario in which the bug is reported. Logger is a class defined in the Java API java.util.logging package. An object ESMSKA logger is defined, which is of the type logger class. A method setLevel is invoked on ESMSKA logger instance, which is supposedly changing the behavior of the object. Following that statement is a line of code that is invoking another method called setUseParentHandlers, which is again trying to modify the behavior of the instance. Now, the problem with this code is that there are chances that the setUseParentHandlers method might depend on the old behavior of the instance before the setLevel method is called. This is one another issue that need to be fixed by the developers. So, in this podcast, we discussed one scary bug and one troubling bug. So far, the bugs that I analyzed in this part seems to be a valid one. In my point of view, these bugs that are reported doesn't seem to be like a false positive and they need to be fixed. To talk about whether these bugs should be reported to the developer or not, definitely yes. These errors are most important and these needs to be fixed. In the next screencast, we will be discussing about of concern bug pattern in detail. Thank you.